11.1 Simple Interest. In this section, we're going to go ahead and start introducing some foundations of financial literacy. In particular, we're going to talk about how does simple interest accumulate? How do we calculate the simple interest? And where might we see simple interest? So, to start us off, let's go ahead and define what is simple interest. So, I'm going to introduce a couple of terms that I'm going to refer to consistently throughout this video. First thing is the principal. So, if I'm depositing money into a bank, investing money into an account, borrowing money from a company or a bank, whatever that amount is, we call it the principal. The interest rate is a percentage of the principal that we use to determine the amount of interest. So before I go further, I want to emphasize there's a difference between the interest rate and the interest amount. So if I were to take an example, let's say I have a savings account with a bank and I deposit $1,000 into that savings account. If that saving account has a 5% interest rate per year, then what we have is $1,000 is the principal. This is what originally we had. And I'm just noticing a typo here. It should be the principal with a PAL, not PLE. But back to what I was saying, the interest rate is 5%, as we have here. So let's go ahead and talk about simple interest in particular. We are going to talk about the other type of interest in a later video, but this one's going to focus on simple interest. So, simple interest is interest that is based on solely the original principal in the interest rate. And we actually have a pretty nice formula for calculating the simple interest. We have the formula I is equal to P times R times T. So, let's talk about what each of these mean. I stands for the interest amount, the dollar amount. P is our principal. Again, this was our original loan or deposit. R is our interest rate, which should be given as a complete decimal. You'll see what I mean in just a moment. And T is the time period. So I want to talk about the interest rate R and the time period T. The rate and the time should match units. For example, if I give you a monthly rate for the interest rate, let's say if it was like 5% per month, then in this formula, I want to make sure that I'm using months for my time as well. And as you can probably guess, an annual or yearly interest rate is the most common thing we'll see in applications. So, unless I tell you otherwise explicitly, we're always going to assume that the interest rate is an annual interest rate. So, let's do a quick example where we apply this nice little formula for simple interest. So, example one, let's go ahead and calculate the simple interest earned in 1 year on a deposit of $1,000 if the interest rate is 5%. So, I'm trying to calculate the simple interest amount. And I'm going to go ahead and underline a couple of other numbers. I see a 1 year, I see a deposit of $1,000, I see a 5% interest rate. So, first thing, I want the simple interest. I want to figure out what is I. And since I'm working with simple interest, I'm going to go ahead and write out that formula we had earlier. I is equal to P R T. So let's identify each of these. I know I want I. That's my end goal. And it's a good idea to figure out what P, R, and T are individually. P stands for principal. How much was our initial deposit or loan? In this case, we're talking about deposits. And there's only $1 amount I'm seeing, $1,000. This will be my principal, P. Next is R, the interest rate. Well, Here it says the interest rate is 5%. This is my R, but I want to be careful. In this formula, remember what I said earlier, we don't want to use a percentage. We want to use the complete decimal value. So what is 5%? 5% is equivalent to me writing 0.05. So how did I get 0.05? Well, to go from a percentage to a decimal, this is what we have as if we wrote it as just a 5. What we're going to do is we're going to take the decimal and move it 2 times to the left, and then fill in the blanks. So 5% is equivalent to 0.05. Next is the time. Here, the interest rate by default is an yearly interest rate. So I want to make sure my time is in years. Well, if I look at this, I definitely have my time in years, in particular 1 year. So I have every variable I need. Now I'm just going to go ahead and fill in the blanks. I is equal to the principal of $1,000 times an interest rate of 0.05 times 1 year. You don't usually have to write the units, but I'm doing it here for the sake of notes for the first time. So if I do 1,000 times 0.05 times 1, you get $50. So we did our calculations, but let's make it clear. What does this mean? What does $50, how does it play into the scenario? Well, the way I interpret this is that if I have a savings account, I deposit $1,000 and I wait 1 whole year where I don't touch it at all. Then in this scenario, I will get an extra $50. So I have my original $1,000 that I deposited plus another $50 in the account. So we just got the simple interest on this type of account. All right, so that's our first example. Let's go ahead to another one just for practice. So calculate the simple interest due on a 3-month loan of $2,000 if my interest rate is 6.5%. So I'm going to go ahead and highlight a couple of things. I'm working with simple interest. I know it's a 3-month loan, $2,000, and an interest rate of 6.5%. First thing is I want the simple interest amount. I'm going to go ahead and rewrite my formula once again. And just like before, I like writing out everything to the side just so that I have it in clear form. I want my interest amount. Make sure we're not mistaking our interest amount for our interest rate. So what about these other 3 things I underlined? So the 3-month loan, this is my time. I have to go ahead and look, do I need my time in years, months, or days? Well, here I didn't specify. So again, we are assuming we are working with years. So what is 3 months in terms of years? Well, there's 12 months in a year. So 3 months is 3 over 12. Or you can say a quarter of a year. So I have my time. Next, I see this 2,000. I took out a loan for $2,000. This corresponds to my principal, P. This again is my original loan in this case. So I have $2,000 that I borrowed. And then my interest rate, 6.5%. Again, we don't want to leave it as a percentage. We're going to take the decimal, instead of 6.5, we're going to move it twice to the left and fill in the blanks. Give me 0.065. It's important that we convert this percentage to a decimal. If you just write 6.5, then you're telling me that you want to pay a loan with a 650% interest rate, which is something you can probably guess that we want to avoid. So I have all the ingredients for my formula, and now we're just going to plug in as needed. I is equal to P, 2000, times my interest rate, 0.065, times my time, 1/4, or 0.25. If I multiply this all together, 2000 times 0.065 times 0.25, we should be getting, if I did my calculations correctly, $32.50. Let's make it clear again, what does this 32.50 mean? It's great that we can do a calculation, but we should be clear about what this means. So, what this means is I went to a company, I asked for a loan of $2,000. They told me, all right, you have 3 months to pay it back with an interest rate of 6.5% annually. I get my $2,000, 3 months go by. At the end of the 3 months, I have to repay the $2,000 that I borrowed plus an additional $32.50 in interest. So don't make the mistake that after 3 months, all you had to pay back is $32.50. It is the principal and your interest. So this is our example 2. All right, so I do have a third example, but we're not going to go through it. I am going to make some notes about it. Reading this, calculate the simple interest due on a 2-month loan of $500 if the interest rate is 1.5% per month. So this sounds very similar to the previous two, but what I want to point out is the interest rate. Notice here the interest rate is 1.5% per month. So, and the difference here is in example 3, my interest rate is a monthly interest rate. What does that mean? That means my time also has to be months. Before, my interest rate was in years, so my time had to be years. Here, my interest rate is in months, so I have to make sure I use months for my calculation. So this is an example that you can go ahead and try on your own, see how well you can go through this. I'm going to go ahead and move on to our next little idea. So far I've given you timelines in years and months. My question is, what if I have a loan that is given in days? For example, what if I give you a loan that is 32 days long? A little bit weird, but it could still happen. Well, we have a way to deal with that. Interest rates are usually given in as an annual interest rate. Sometimes you might see monthly, but most of the time they're annual interest rates. But let's say my time period is given in days. Then, as you can expect, if I have an annual interest rate, I need to make sure I work with the years only. So if I have days, I need to change those days into years. So there's actually 2 ways that we can talk about this. First one is probably the one that you're thinking of. Well, if I want to go from days to years, how many days are there in a year? About 365. I'm not going to talk about the extra little 0.25 from a leap year or anything like that. But generally, most people are going to say 365. So one way is take the number of days, divide it by 365. We've got years. This is what we call the exact method. It's what we would usually use if we're doing day-to-day language. What does that mean for the second method, ordinary method? Well, the ordinary method is going to be a little bit different in the fact that we're going to divide by 360 instead of 365. Now, you're probably wondering, why are we going to use 360? Well, I want you to think about the months of the year: January, February, March, April, May, so on and so on. How many days does each of those months have? Well, I don't know the exact number off the top of my head, but some have 31 days, some have 28 days, some have 30 days. My point is, not all of those months don't have necessarily the same number of days. So keep things a little bit simplified, we have this ordinary method. This is based in the idea that we have 12 months and we have about 30 days each month. So 30 days times 12 months, that gives us 360 days, roughly. So this is the ordinary method for calculating and converting from days to years. And this method is actually often used by most businesses and banks. So since we're following heavy into the application, unless I tell you otherwise, we are only going to be using the ordinary method. That is, we're going to assume a year is 360 days for simplicity. All right, so using that, let's go ahead and look at this. Example 4, calculate the simple interest due on a 45-day loan, $3,500, if the annual interest rate is 8%. So again, I want the simple interest amount. I want I. So I'm going to go ahead and still use that same formula. I'm going to write all of my variables here. I want the interest rate I. So I'm going to leave that blank. So let's go down the list. P for principal. That is my original loan amount. What did I borrow? In the scenario, I borrowed $3,500. Next is R. What's my interest rate? Well, my interest rate is 8%, or as a decimal, 0.08. And if you want, you can make a little note here. We didn't do it before, but sometimes it might help if I just put a little note of yearly, 8% yearly. Next is my time. Well, since my interest rate is a yearly interest rate, I need to make sure my time is in years. Unfortunately, I only have it in days, 45 days. Well, if I want to change this to years, remember, I'm using the ordinary method. So I'm going to do 45 over 360. That will give me the value in years. All right, so now I'm going to go ahead and plug all these in. P is $3,500. My interest rate R is 0.08. And my time is 45 over 360 years. If I go ahead and multiply this all together, assuming that I have multiplied this all nicely, we should be getting an interest amount of $35. Again, this is a loan. So this is telling me I took out a loan of $3,500 with an interest rate of 8%, and it's a 45-day loan. After 45 days, what do I owe? I owe 300 $3,500 plus an additional $35 in interest. One thing I want to know about all these examples is that we're working in very ideal scenarios. Let's not say that you make loan payments along the way or anything like that. Let's just say that you took out a 45-day loan, you didn't touch anything about it until the end of the time. But this is our example 4. All right. As a little bit of a challenge problem, I'll also make note of this. I won't go through this one either, just for the sake of time. This one is suppose you were charged $150 simple interest on a 6-month loan of $3,000. Calculate the simple interest rate. The reason why I call this a little bit of an extra challenge and a little bit different is that here we want the simple interest rate, not the simple interest amount. So I'm still using the same formula, but what I want to find is I want to solve for little r. Last time I gave you r and we found I. This time I'm giving you I. Can you give me the interest rate? So again, if you want, you can take some time, think about this problem, and then try it out for yourself. Fortunately, the only difference is that where we are solving for. What are we solving for? All right. The other thing that I wanted to talk about in this section is something called a maturity value or future value. So, if I'm talking about loans specifically, the total amount that I have to repay, so in other words, how much I borrowed plus the interest, this is called the maturity value. How much are you paying at the end of all of this? On the other hand, if I'm talking about investments, deposits, anything like that, then we call it a future value. That is how much I invested plus the extra interest that I earned. So the good news is that both of these formulas are from the same idea. We're not going to change up the formulas between these two. Here I have A. This will represent either maturity or future value. Again, these are both very similar, just that one means for loans, one means for investments. We use the letter capital A. This is the principal plus interest. Or if I clean it up, we have P times parentheses 1 plus RT. So this is for getting the total value of repayment or the total investment portfolio what it's worth. All right, so let's do a quick example with this. Calculate the maturity value of a simple interest 8-month loan of $8,000 if the interest rate is 9.75%. First thing I'm noticing here is that I am calculating maturity value. So I want the value A. What's happening in this scenario? I took out a loan of $8,000. The company told me, all right, we'll give it to you at a 9.75% interest rate for 8 months. What I'm doing with this maturity value is I'm calculating how much will I have to repay in total, which should be just my original principal plus any extra interest they might charge me. So I'm going to go ahead and write down the formula we had earlier. Maturity value is principal times 1 plus R times T. I want A. I need P, R, and T. Principal. How much did I borrow? In this case, I'm borrowing $8,000 from a company or a bank. Interest rate. We have 9.75%, or as a complete decimal, 0.0975. Always make sure we convert our percentage. Next is the time. How long is the time of this loan? It's 8 months. Now, looking at this with my interest rate, a daily, monthly, or yearly interest rate. Well, we didn't specify, so we assume it's a yearly interest rate. I'll write that down. Therefore, my time has to be years. So instead of 8 months, I'm going to write this as 8/12. So I have everything I need, and now I'm going to go ahead and plug it into my formula. Principal of 8,000. 1 plus the interest rate, 0.0975, times the time of 8/12. Or you can say 2/3. Now, I want you to be careful if you're using a calculator here. I'm going to do this one step at a time just to make sure that we're doing this correctly. 8,000 is pretty clean. 1 plus 0.0975 times 8/12. I believe we should be getting 0.065. And let me just confirm that real quick on the side so that I don't accidentally write down the wrong solution. Let's see, 8/12 times 0.0975. Yes, we have this. That was me cleaning up the parentheses by multiplying. I can go ahead and add the 1. So 8,000 times 1.065. And then I multiply these. So if I do 8,000 times 1.065, we should be getting a dollar amount of 8,520. So again, this is my loan. I borrowed $8,000. How much am I going to be paying for this loan in total? Well, I'm paying back in total $8,520. 8,000 of that was from what I borrowed, and you can probably guess the remaining 520 was extra interest that I'm paying off. So this is our example 6. All right. Besides that, that's all I have for you in this video. I'll see you for the next one.